Hello everyone, hope you all are doing well. So now we will start our next topic, that is linear momentum of body. Talking about linear momentum of body, the simple momentum and the linear momentum both are same. The first point of the linear momentum of the body is that the quantity of a motion is called is present in a body is called linear momentum, or you can say momentum. The quantity of motion means how much motion is happening, like having mass and velocity. The quantity of motion in a body is called momentum. Second point we are having that we are having a product of mass. You can write here a product of mass and velocity. We can write different definitions of this. Is called a product of mass and velocity is called momentum. Okay. After that, now we should define a momentum, that what actually momentum is. So talking about momentum, first of all we will talk about its symbol. Secondly, we will talk about its product, that which kind of product it is. Third, we will talk about what we can say symbol. Then we'll talk about product, then SI unit and dimension. Then we will talk about its SI unit, then its dimension, and lastly same as. Okay, so these things we will do now in momentum to understand momentum very clearly. So just wait. Okay, now it looks better. Okay, so talking about its symbol, the symbol of the momentum is, it's represented by P. It's the simple product. Simple product means simple product is done by with cross. It's a simple product. Talking about its SI unit, the SI unit of momentum is Newton second, but we should also know that how its unit is Newton second. So we are having a kilogram. Like we will take our further we will move, so we will take out its SI unit, that how its SI unit is Newton second. For till that we should talk about its MKS unit, that in MKS system it's kilogram meter per second. In CGS we can say kilogram meter per second. Kilogram will change in CGS, it will be gram. Centimeter, second will remain same. Okay, second. So this is the MKS CGS as a unit of momentum. Let we will know that how as a unit of momentum is Newton second. So I will explain you with that with proof formula. Talking about its dimension, kilogram, m, meter, l. Time is upon t. When it will move up, it will be t minus 1. Okay, it's plus 1. Here will come t minus ml. T minus 1 is the dimension of momentum. It's same as impulse. How it's same as impulse, we will also do that further. That is same as impulse because the impulse is also force into short interval of time. And the SI unit of impulse is also Newton second. Okay, now let's move further. We should also explain it mathematically, that how mathematically it happens. So mathematically we'll take that P is equal to mv. P is equal to mv. We know this is the formula of momentum. P is equal to SI unit. We are taking out its SI unit. M in MKS, m is equal to kilogram. Velocity is equal to meter per second. Okay, so this is its SI unit. Talking about its dimension, its dimension is P is equal to kilogram ml upon T is equal to again ml T power minus 1. Okay, so mathematically we have proved that how we have to write this formula, their SI unit and their dimension. Now move towards one more topic, that we are having the rate of change of momentum. Means how momentum will change, what is the rate of the momentum that momentum will change over there. Okay, so the rate of change of momentum. Talking about rate of change of momentum, so we can write here the rate of change of momentum is equal to force. How it's force? According to second law of motion, we are having F is equal to m vf minus m vi upon t, short interval of time. Okay, this mv we have represented with you can say it's represented us about what about momentum mv and final velocity of final momentum and initial momentum. Okay, so talking about f, here we'll write is equal to mv and mv, both are the representing the momentum force, so we will write here the change in momentum, we can replace it with p upon t time. Okay, because there is the formula of mvp is equal to mv, so we will write change in momentum upon time, force is equal to. After that what we will do, that change in momentum will remain here on its place, so is equal to t is dividing over here, it will multiply over here, it's f multiply t. Now you can check it out, that f multiplied by t, as we have done in impulse, that impulse is f into short interval of time, so it's also same as impulse. Here we have proved that it's same as impulse, and we have also proved that the rate of change of momentum is equal to force. Now one more thing, that the second thing, the rate of change of momentum is equal to force, so the change of momentum means that was a rate. Now we will write here the change of momentum is equal to what? Is equal to impulse. Okay, so this is about impulse that we have proven out. Now let's move further to prove about unit of linear momentum is also Newton second, as I told you that I will also prove that. So prove SI unit of linear momentum. Okay, so let's move further. Just wait, what's going on? Okay, so we will move further. The we have to prove that as a unit of linear momentum is Newton second. So we will take here a formula, that is P is equal to mv. After that we know that S is equal to kilogram weight. P is equal to kilogram meter per second, kilogram meter per second. Okay, now what we will do, we will use here one formula, the divide and multiply by second. We will also divide it and multiply it by second, so when we will divide and multiply both cancel, so we will again receive a value of kilogram meter per second. So kilogram meter per weight, meter per second. Here we will write multiply by second and divide by second. Now you can see that second is multiplied by with kilogram meter, so we will write here kilogram meter second. Okay, and upon second is multiplying with second, so it will be second square. So we can write here that kilogram meter per second square into second. Okay, 1 second is remains, so we will write here multiply by second. Now as we know that kilogram meter per second square is equal to Newton, so we will write here Newton or should I write complete Newton. After that second will remain same, so it means that the SI unit of linear momentum has proved that the SI unit of linear momentum is also Newton second. Hope you understand today's lecture. Thank you so much for listening.